Okay, let's do the third and final of our trig equations. So, why is this a bit harder? There's a squared going on, and look at this, look, there's pi's everywhere. There's pi. We're dealing with radians here. So the first thing I'm going to do, so I don't get caught out later, is I'm going to set up my calculator to work in radians, please. Great, good start. Now, let's solve that. How am I going to solve that? I want to get to k. I want to have tan on its own. So let's divide by 10 first, shall we? Tan squared of 2 pi over 3 minus k is going to be 5 over 10, in other words, a half. Now, tan squared, what does that mean? It's a notation. It just means tan squared of x is an easy, quick way of writing tan x all squared. So how do I get rid of it? I square root the whole thing. Square root the whole thing, please. Tan of 2 pi over 3 minus k is going to be square root of 1 is 1, square root of 2, 1 over root 2. Some messy number. Okay. Now I'm dealing with tan on its own. I'm dealing with the tan graph. So let me draw my tan graph at this point here. Okay. Here is my tan graph effort. And we're just going to have a real big one just for the fun of it. Okay. So it goes up something like this. And it kind of just keeps doing this. It keeps repeating. As with all the trig graphs, that's kind of the point. Okay. I have never really done it backwards much before. That's terrible effort. There you go. You get the idea. And it keeps repeating up like this. So what's going on? This change over here happens in 90. And this crossover here happens at 180. When we're in degrees, we're in radians. So we're going to convert these things. Instead of 90, we're going to have pi over 2 because we know that 180 is worth a pi. Okay, so this point here, we're going to call that 3 pi over 2 or 1.5 pi's. And here I've got to 2 pi's. Here I've got obviously minus pi over 2. Here I'm going to be at minus pi. You get the idea. Okay, so we can convert them. And the reason I'm doing this is the SQA is super fussy. You might think, oh, I'll just switch that into degrees and work in degrees the whole time. The SQA is super fussy. If the question's in radians, they want you to work in radians. Okay. Right, let's find some answers. So, calculator, help me. I need to know inverse tan of 1 over root 2. Okay, inverse tan, what happened there? Inverse tan of 1 divided by the square root of 2 is going to be what? 0.615. So, inverse tan now, 2 pi over 3 minus k is going to be 0.615. What happened from here to here? There you go, you can see it now. What happened from here to here? Get rid of the tan by doing inverse tan of that. And I get this. Okay. Right. Now what I can do is I can go ahead and solve this equation. I'm going to add the k onto this side, subtract that onto this side, and I'm going to get k equals 2 pi over 3 minus 0.615. And I'm going to say, calculator, help me please. What is 2 pi divided by 3, take away my answer, 1.4789 apparently. So 1.478. That's loads of enough. Really, I should probably round that, but anyway. Okay, that is one answer. Does it live in my range of required answers? Well, let's just kind of, just check in. How big is 2 pi? Well, 2 times 3 and a bit, it'll be 6 and a bit, right? So 6.28. So here we go. That's 6.28. I want all the answers for k that live in here. So I've got a good start there. Where are the others? Well, this here, 0.615, where does that live? Let's just check out. Pi divided by 2 is going to be like 1.6. So 0.6 is going to be about here. 0.615 is there. And that height there is going to be my 1 over root 2, whatever that number is. Where else am I at this height? Where else does tan of my thing give me 1 over root 2? Well, if I go across, it happens again here. I get to the same place. And it happens again here. And just for completeness, it also happens again here. And it happens again all the way over here. All of these places give me the same answer. This y coordinate, the answer, the outcome of the curve is at the same height, all of these places. So where are they? This one is 0.615 across from the middle here. Just how that was 0.1615 across there. This was at pi already. So my answer here is going to be at pi plus 0.615. So let's put that into my calculator. Pi, what happened there? Pi plus 0.615. And this is going to be 3.756, etc. Okay, right. That is not k. That is 2 pi or 2 pi over 3 minus k could equal 3.757. Fascinating. K would be 2 pi over 3 minus 3.757, which would equal what? Let's find out. What is 2 times pi divided by 3 minus 3.757? Ah, that's interesting. Negative 1.66. So I've got one answer here. I've got one answer here. But this is no use to me because it's outside of the range requested here. Okay, so what do I need to do? I need to go backwards instead and look at this one. This one here, let's call it star. Star is going to be at minus pi. That there is minus pi plus 0.615. So type that into the calculator. Let's try again. Okay, so try again. Minus pi plus 0.615 is going to be what? Negative 2.527. And then what am I going to do? I'm going to have 2 pi over 3 minus 2.527 is going to equal k, which is going to equal, let's have a look. Let's do that times minus 1 to get positive, and then we're going to add that on to 2 times pi divided by 3. And there we go, that's another answer, 4.621. That lives within this zone here. And if you wanted to, for completeness, you could check this one. Minus 2 pi plus 0.615, and you'll find, I'm afraid, it's outside of that range. So the key is that you've got two answers here and here.